Righto.
Hi, I'm Dan and welcome to my shed. Well, I want to go on to the next part about making a bronze plane, and today what we're going to talk about is the actual moulding, the gear that you need for the moulding process. The next one we'll do will be the moulding of the plane. And so what gear do you need to melt down your product, your aluminium, to make the aluminium bronze material? So what you will need is a furnace. Now, oftentimes people call this a foundry, but this is not a foundry, this is a furnace. The foundry is the building in which you put the furnace in. And so this is a little furnace that I've made up, and it's very, very simple. And you can make this up quite cheaply. And so on the outside, I just made that up out of some corrugated iron, mini corrugated iron, wrapped it around to a circle. First place where I started is deciding how big a melt that I wanted to do, what size crucible. And this is the first place to start. Now you see this one here is a smaller one, a salamander one, same height basically, but not as big a diameter. And so this is about a 5 kilo, this is a 3 kilo crucible. You get these off eBay cheap enough. This being a salamander is a higher quality one, but the amount of pouring that most people do, one of these would be quite adequate. This is one here that I've obviously overheated, and you see what's happened to that, but I've had quite a few pours out of that, and I probably could use that a little bit more, but I've overheated that at one stage and melted it. So the first place you start.
What are they made out of?
These are made out of carbon, and yeah, I don't know the process they use to make them, but yeah, it's a graphite. Sorry, graphite crucibles. But to start with it is look at, this is about a 5 kilo. Get the diameter of it. Now, when you want to make a furnace, then is that you want to be able to have it so that you've got about 35 mil either side of the crucible, and that gives enough for the flame to come around. And so when we're making one of these is work from there. The size of the crucible, add about 35 mil, this might be a little bit further, and then this is what we call refractory cement. You can buy this off the net easy enough. There's people that sell that. And this refractory cement is about 20 mil thick, and then on the outside of that then is about 25 mil, 20 mil of insulation materials, just like a fibre bat that's heat resistant fibre. And so then you set the diameter of this, then you put your wool in there, apply that up, then make a moulding thing, and then pour this. So when you make the furnace, which I didn't do here, as I should have, is put a hole in the bottom in case you actually get some melt down inside there. As you can see there, it'll go out the bottom. Also making one of these, I put that in there, put a piece of cardboard underneath it, put the crucible on top. And the idea of the cardboard is that the cardboard burns, pours a layer of carbon there and stops this sticking to the bottom. So you have this at about 35 mil clearance there. Then very simply making a burner and putting a burner in it. And so the idea is to have it at an angle where it's going to get a circular motion coming up around the crucible, and you can see the angle of that, and that could be even at a little bit more angle. If you have it coming in straight in at the crucible, you're going to get a hot spot, and you'll find that you'll heat that up one spot too much, and you don't want to do that. And so the idea is to have it at an angle, and then it creates a vortex and comes up through the top then with about 100 mil hole at the top. The top is basically the same as the size, where you have the refractory cement, and then you have your glass wall on top of that, and then on top of that I've just put a bit of cement on top of that, which is quite easy. So it's not hard, it's not expensive to do. Bit of trial and error. Now with the burner, this is a burner that I've made for a little forge, and so these burners, you can get the designs off the net very, very easily. You can get a piece of pipe, that's a reducer pipe, to come down to this. This is 3/4 inch pipe coming up to about an inch. I've made this out of 316 stainless basically because what was happening, it was carburizing and it was going into scale, and I ended up wearing them out. And so I've made this one out of stainless where I don't get the scale forming there. And I've made this one, this design here. This is a bit of threaded bar. The tip is a MIG welding tip. Now I found a 0.9mm hole in there, the best size. Basically because you can get the thing to temperature that you want to make bronze or brass, and it'll melt that down without going through too much actual gas. And so bigger than that, you're going to use a lot of gas, and you might say I can heat it up quicker. I can put a full melt in that, at least 3 and 4 kilos. I can get that melted in 3/4 of an hour, 40-45 minutes is molten, without going through a lot of gas. And I take that long because I want to heat up all the refractory of the furnace slowly. If you heat it up too quick, you're going to get a lot of cracks and uneven heating. And so heat your furnace up slower. And I find a 0.9mm tip really, really great. A good size, economical on gas, and still get the... So you want about 1100 to 1200 degrees centigrade for melting or pouring bronze, and this size tip will actually get that temperature for you in an economical way. And so I've made this up. You haven't, and this is the baffle, as you can see in here. That's the baffle that opens and closes for the air, and this is the baffle here. I've used this threaded bar here. Now, you may not have a welder and things like that to do that with. You can just get a reducer here, pipe reducer. I think it's about 1.5 to 3/4. Screw it on, same the other end. And if you don't have a welder, you can actually drill a hole here, put a piece of copper pipe in there, like that, and then drill a hole there for your nozzle. And then the baffle, you can just have it so that you can slide it open and close it. This one here, I've made it so that it opens and closes that way there. Why did this is not a better design than the other. I just had a bit of fun making it, that's all. And so this then screws in here, fits in there about that depth there, and this is what you end up with. And so what you do is you have it so that you have a converging, diverging nozzle. And the idea of this nozzle, this here, is it slows the airflow down when it gets here. If you don't have that on it, your flame will actually leave you and you won't be able to keep the burner going. And so it slows the flow, because you can imagine when the air comes in through here and coming in through a smaller pipe here, the air's got to speed up to go through there. And you want this length here. You can get some really good designs off the net. That gives time for the air and the gas to mix properly. But then you want to slow it down again when it gets down to here, and that slows the whole airflow down. And so that's what you need for the burner, which is, you know, you can make them up very, very cheaply. You want an on-off valve. This is a ball valve that I've fitted. You can get gas ones, but you need one of those so you can turn it on and off quite easily. You want a good length of hose so that you can have your tank, your gas tank, a feed distance from the actual furnace. You don't want it too close. Then you need to get a regulator. This is probably one of the most expensive parts. You can't use a barbecue regulator for it. There's just not enough pressure. And so with mine, to melt with that size tip and this size burner, I heat it up at about 50 kilopascals. Then I increase it up to 100. And at 100 I can get to melting temperature quite easily with that. And so that's what you need. It's an adjustable. Don't try and do it. This is a Uni-MIG. You can pick them up at your hardware stores easy enough. And they do a beautiful job. And so that's the furnace that's involved. You want to have it so that you can open and close this, of course. Now there's a lot of different ways different guys use to open and close their furnace. I've got this way here. It could be improved, and so it closes down. Some people, you make them up out of rubbish bins for the outside case. It really doesn't matter. I've hinged this one. Some have it so that they lift up and then come out, but whatever way works for you. And so it's quite simple to make. A little bit of sometimes trial and error. I've made this one up and it works very, very well. I've done a lot of pouring with this one, melted a lot of bits of metal, and it's lasted me very well. You just got to heat it up slowly and cool it down slowly. That's your trick, so that everything slows and heats up, cools down and heats up at a slow pace. When I'm finished with, after I've poured, I put this back in here and just close it up. And that way there, the whole thing might take 6 hours to cool down and cools down really, really, really great. And so that's the furnace that's involved.
So when you're using it, you close the top and slowly feed stuff in to keep that heat in the whole thing.
Yeah, when I'm using it, what I do is I obviously have that closed, and then I'll just stick, say I'm melting copper, which is normally old copper pipe. I'll have it sitting here so that the flames are coming in and it's preheating all the copper and drying all the moisture out. Because one thing you don't want in there when it's heating up, you don't want moisture. You don't want any water at all in there. And so that's the way I heat it up there.
Why no moisture?
Because moisture will cause it to explode. Any moisture gets in there or in your moulds, it's what you really don't want. And so that's the heating equipment that you use. Now that the tools that go with it is I've made this thing up very simple, bit of deformed bar, bit of stainless steel on the end, and that's I just shape that to the shape of the crucible, and that's for scraping off the dross off the top. Very, very simple, very easily done. Then you need these tongs. I make these tongs here, just that goes over the top. Then you can lift it up and sit it in the actual pourer. And so that sits in your pourer there like that. Then it's just a matter of lifting it up. This one here's been adjusted to the other one, sorry. So it's just a matter of lifting up out of your furnace into there, up here, and that so that you can actually pour it. Now the key is with this here is have it so that this comes up so most of your weight is underneath this here. The last thing you want is to have this down here and have no control over it. And so you can see here where I've actually cut this because of different size crucibles. I'll open that up a little bit and close it a little bit so that it fits better. And so that stop a bit there, and then that enables me to have full control over my pouring. And so that's the idea of it there. I see some guys, they have it so that it lifts from there, and so it means you've got too much weight above, which makes it very, very hard to control. And you see guys pouring their metal, next minute the crucible falls out of the holder. So the idea is to put that there in some way that's going to hold it in there nice and good while you pour it. Okay, so that is the gear. Now that's not hard to make. They're not hard, those tools, but you really do need them if you're going to do any pouring. Okay, so the next thing we've got to look at after we've got that is safety gear. Safety gear is vital. So if you're going to wear glasses, get some good, these are safety glasses, these are prescription safety glasses that I've made. And don't skimp. Look guys, honestly, I see a lot of guys skimp in this area of safety. So it's a good set of safety glasses. Then it's about having a full face shield on top of that. Because if you have any problems at all, honestly, you're going to end up very ugly if it blows back at you. And so it's about having a really good face shield with your safety goggles behind it. But also want to make sure you got his good safety boots. I'm not wearing them now, but good long trousers that go over the top here. Some guys wear spats, which is a really good idea. And a good long sleeve shirt. And making sure that your shirt and your duds are cotton and not nylon. If they're nylon and you get stuff that melted, that the nylon will melt to your skin and it'll be very, very painful. So having good long sleeve shirt, long duds that cover your safety boots. And I know it's hot. I live in Queensland and it's very, very hot, but moulding is a hot business. And so having that, on top of that, I wear an apron. And so that apron there is going to cover me up really well and truly. By the time I get my face shield on, my apron on, and a really good set of welding gloves, leather welding gloves that come up over the top of the long sleeve shirt, and that way there you're protecting yourself. If you don't, you're going to pay the price. Sooner or later something will go wrong and you'll end up sooner or later you'll end up getting molten metal on yourself, and that's not a lot of fun. I worked in a foundry once where a guy got molten metal down his boots and it just burned and burnt through his feet. Had a heck of a hard time with it. So safety gear cannot be compromised. And if you get all of that there, you're going to have a lot of fun. Now, one thing you're going to do, you're going to pour at times and something's going to come out. You might be pouring having a go at this and it comes out no good. Well, that's all right. Remelt the metal. Don't push yourself. Don't rush. There's times when your mould is not going to work well. And you can see this has come out quite good. And this is just using green sand, what I showed you in the video before this one. And just persevering, trying. None of us are perfect. This has come out really good. There's no porosity in there. The surface has come out really well, and have fun with it. Have fun. And just before I close, with this burner here, I've made up a little portable forge as well. And so the same burner design can actually fit in my forge, and away I go. And so this is a little portable forge that I can take that out, that can go in there, and away I go. I've got a little forge, I've got a little back piece that can come off if I've got something long to heat up, and so the same design burner for that will work in here, and the principle's pretty well the same here with my refractory cement. It probably could have been a little bit higher, and it'll work for you. So your burner and everything else can all work in multiple works. Okay. Thank you for watching. Happy making.